Hi guys, welcome back to Worms Maths Academy. Right now we're going to be going through the derivative by the rule. Okay, so derivative, gradient, if you substitute a point in, it's the gradient of the tangent at that point. So they can call it the tangent, they can call it the gradient, they can say the instantaneous rate of change, they're all the same thing. Okay, so the rule for finding the gradient of the tangent, or the rule for its derivative, we bring our power down to the front. So bring that power down to the front, multiply it, so f of x is 5 times 3 is 15, and then we subtract 1 from the power. Likewise here, minus, if we bring that 2 down the front and multiply it, we get 4x to the power of 1. So our derivative is 15x to the 4 minus 4x to the 1, or just 4x. Now, if you had done that by first principles, you'd get the same answer. It'd just take you a hell of a lot longer. Okay, so in this case here, g dash of x, we bring our 3 down to the front, 18x squared. So we brought our 3 down, multiplied it by the 6, and then took 1 away from the power. Minus 4, I have a 1, if I bring it down to the front and multiply it, that becomes x to the naught, which we know x to the naught is just 1. So we get 18x to the negative 4. Okay, here, find the derivative of that, and hence find f dash of 1. So that means find the gradient, or the formula for the gradient. So the 3 times 4 is 12. X squared minus 7, and then we want to know it when x equals 1. So f dash of 1 is the gradient at the point 1. So we're going to get 12 times 1 squared minus 7 is 5. So the gradient of that curve when x equals 1 is 5. And we can do that on our CAS. I'm going to clear whatever's here. So we can say 4x cubed minus 7x plus 4, highlight, interactive calculation, diff. Now if you just diff it, it just gives you the derivative, which is what we got. Highlight interactive calc diff, and then if you choose, oh, stupid thing, interactive calc diff, and we say at a point and x equals 1, it'll tell us that it's 5. How do we do it on this case? We go to add calculator, menu, calculus, derivative at a point, the value is 1, click OK, and then we just put it in here. What's our function? 4x cubed minus 7x minus 7x and then plus 4, given x equals 1, so we get 5. If you wanted to do it without using that, you can push shift, I think it is, and minus, gives you ddx, and then we just put in our function, so 4x cubed minus 7x plus 4, and then on the outside we say given, so shift equals, or control equals, given x equals 1, enter, we get the same thing. Okay, so that's using the CAS. Find the gradient. Now here it says find the derivative and find the value of that. Find the gradient of that. So the gradient at any point is f dash of x, the instantaneous gradient, or the gradient at any point. So we're going to get 12x squared minus 7. Oops. Put the basketball going in the background and have to see what's happening. Okay, so 12x squared minus 7. Now it says at the point that in methods you're only ever going to worry about the x value because we only ever find gradients at x values. So I keep scrolling this. So f dash, go back, f dash of 1 is 12 1 squared minus 7, which is 5. Now these are actually the same question. Find the gradient or find the derivative. If you find the derivative at a point, or if you find the gradient and sub in a point, it's the gradient at that point. So it's just different wording, and I was just trying to get you to see that the different wording, it actually gives the same answer. Using your CAS, well, I just went through how to do that on your CAS. So that's using the rule. Okay, now when you have different variables, if you want to find the derivative, here, because it's not y and x, because it's z and x, our derivative is dz dx, which is, so I'm finding the rate of change, that's what this means, dz dx. That means the change, oops, that should be a z and x. That should be, can't find my bloody rubber. That should be the change in z over the change in x. Now, if it was y, actually I'll show you with y, it makes more sense. If I said, what's the change in y over the change in x, or the change in y over the change in x, if you had a curve, just say at that point, the change in y over the change in x that's your gradient. And if we make our change in y really small and our change in x really small, we get our instantaneous gradient. So that's where dy dx comes from, the difference in y over the difference in x, the rate of change of y with respect to x. Okay, if I derive it, I get 6x. If we derive with respect to t, we get dx dt is 14t minus 4. Here we're going to get dA dB, which is 3b squared minus 10b. Okay, if I want to derive this, we could use a chain rule if we know how to use a chain rule, or I'm just going to pause this for a second. Okay guys, we're back. My team Philly got up, so I'm happy. Alright, if we want to derive this, we could use a chain rule. If you haven't learnt that yet, you can just expand it. So first we say y equals, let's zoom in a bit, 4x squared minus 20x plus 25 dy dx. We get 8x when we bring that 2 down to the front, minus 20. Here we need to simplify it first, so y equals x cubed on x minus 4x on x. They cancel, that will make that a 2, and we have to say x can't equal 0 because we've gotten rid of an x on the bottom. Therefore y is equal to x squared minus 4, and dy dx is 2x. This one here, once you learn the product rule, you could use that. However, it's probably easier just to expand it. So, sorry, I kept moving the screen. Okay, y is equal to this first bracket expanded, x squared plus 4x plus 4 times x minus 4. So y equals x cubed minus 4x squared minus 16x. Sorry, I forgot the plus 4x squared. Can't find my minus button. Okay, so x squared times those two gives me x cubed minus 4x squared. 4x gives me 4x squared minus 16x. Then I get 4 times x, so plus 4x, and then minus 16. So y equals x cubed. They're going to cancel. I'm going to have minus 12x minus 16. So dy dx is 3x squared minus 12. Okay, here it's a notation thing. Usually we have y is equal to x squared minus 4x. Sorry, x minus 4x squared. And then we say dy dx is 1 minus 8x. However, here we don't have y equals. We've just got a thing outside that's saying what's the derivative of whatever's in the bracket with respect to x. So in this case, our answer is 1 minus 8x. And that's what our CAS does when we derive something. If I said x minus 4x squared, if I go keyboard and then diff, it just says what's the derivative of what's in the bracket? 1 minus 8x. Here, what's the derivative in the bracket with respect to z? Well, 20z minus 12z squared. Here, what's the derivative of what's in the bracket with respect to z? Well, it's 18z squared minus 8z. Okay, for each of the following curves, find the coordinates of the points on the curve which the gradient of the tangent at the point has a given value. So we've got the function y. If I want the gradient, or the gradient of the tangent, we get dy dx, which we know is 3x squared. And we know that 3x squared has to equal 27. If 3x squared equals 27, x squared is equal to 9, x is equal to plus or minus 3. Now, find the coordinates, so we've got to find the y values as well. So to get the y value, we substitute in the x value into the original function. Don't sub it into the derivative function because you're just going to get 27. So in this case here, we've got the point 3. When we sub 3 into the original function, we get 27. And then we've got the point negative 3. When we sub that into the original function, we get negative 27. So they're the 2 points on that curve where we have a gradient of 27. Okay, here, when does that parabola have a gradient of 0? i.e. when is the turning point? So first we say dy dx is equal, it's a turning point because it's a parabola, it could also be a stationary point. It's 2x minus 8, dy dx equals 0. So 2x minus 8 equals 0, x equals 4. Now we need to find the coordinate, so if I sub 4 back in, I get 16 minus 32, which is minus 16, plus 1 is minus 15. So that's where we've got a turning point. Okay, where on this curve do we have a gradient of negative 12? So dy dx equals negative 3x squared. So negative 3x squared is equal to negative 12. X squared is equal to 4. X equals plus or minus 2. When x equals 2, 4 minus 2 cubed, 4 minus 8 is minus 4. When x equals minus 2, 4 minus 2 cubed is minus 8, so 4 plus 8 is 12. So there's our points where the gradient is equal to negative 12. Okay, find the coordinates of the points on the curve that at which the tangent makes an angle of 45 degrees with the x-axis. Now we know our gradient is equal to tan theta. So in this case, our gradient is equal to tan of 45, which we know is 1. So I want to work out when this line has a gradient of 1. So dy dx is equal to 4x minus 7. Set it equal to 1. 4x is equal to 8. X is equal to 2. So we've got 2 when we sub 2 back into the function. 2 times 4 is 8. Minus 14 is minus 6. Plus 8 is 2. So that's our point where the gradient equals 1. Next is parallel with that line. So in this case, m is equal to 3. So we get 4x minus 7, our gradient, because that hasn't changed, is equal to 3. 4x is equal to 10. X is equal to 5 on 2. Therefore, y is equal to 5 on 2 squared times 2 minus 7 times 5 on 2 plus 8. That's going to be 2 times 25 on 4, which is 25 on 2, minus 35 on 2 plus 8. 25 on 2 minus 35 on 2 is minus 10 on 2, which is minus 5. When we add 8, we get 3. So we've got the point 5 on 2 and 3. And we know we can do that in our cas. So if I've got 2x squared minus 7x plus 8, we want to find when the gradient of that, the derivative, d dx, is equal to 3. We want to solve for x. Okay, so x equals 2.5, and then we can just grab that value, bring it down here, and say given x equals 2.5 to find out what our y value is, which is 3. Okay, on this cas, I'm just going to add another page. So I've got 2x squared minus 7x plus 8. Now, if you don't know, you can push Control A on your keyboard and that'll highlight everything. Then we go menu, 4, 1, d dx. When does that equal 3? Whoa, what's that? When does that equal 3? That's bizarre. Okay, Control A, menu, 3, 1, we want to solve. We've got to put a comma x at the bottom of this one. Comma x. Okay, so we get 5 on 2. Then grab that, bring it down, and say at the end, given, control equals given. Grab that and bring it down. Okay, I'm just going to write x equals 5 divided by 2, enter, we get 3. Okay, so that's doing both of them on the cas. This is an exam 1 question, and it requires you to know the chain rule, which I didn't realize, well, I didn't think about when I put it in. We can rewrite it as f of x is equal to 1 minus 2x to the power of a half. The derivative, f dash x, you bring your half down to the front, multiply it by the derivative of the bracket, which is negative 2, multiply it by the bracket and take 1 away from the power. They're going to cancel out, so we're going to end up with negative 1 on, because that's the negative a half, it's square root on the bottom, 1 minus 2x. So when you derive a function to a power like we've got here, if I had y is ax plus b to the power of n, when I derive it, dy dx, it's n times the derivative of that bracket, which is a, times ax plus b to the power of n minus 1. So that's called the chain rule, but we will go into more detail in that later. Okay, find the angle theta from the positive direction of the x-axis to the tangent to the graph of f at x equals -1, measured in an anti-clockwise direction. Okay, so what we want to do, when x equals -1, whatever the tangent is, so it might be something like that, we want to find the angle from the positive direction of the x-axis in an anti-clockwise, so that's anti-clockwise. Okay, so first we've got to find the gradient of the tangent at x equals -1. So we sub that into the equation. So f dash of -1 is -1 on square root of 1. If I put -1 into there, I get +2. So it's negative, I'll put +2, but I put +3, but I meant 2. So I get -1 on root 3. We know we can use a special triangle for that. 1, 2, root 3. The angle is pi on 6. However, because it's negative, it's got to be in the second quadrant where tan is negative. So find the angle. Our angle is going to be pi minus pi on 6, because we know the angle's pi on 6 in there, which is 5 pi on 6. So we know it's in the second quadrant because it's negative, and we know it's going to be more than 90 because it's negative. When you've got a gradient that's negative, it's got to be between 90 and 180 degrees. And we know that it equals 5 pi on 6 because it's pi on 6 off the axis. Okay, so that's it for that topic. I'll be coming back soon to do gradients of, or gradient graphs of functions. Until then, good luck with derivatives using the rule. See you later.